Assalamu alaikum. Good evening, sir.
Walaikum assalam, Ibha. Good evening. Hope you are doing well.
Yeah, Alhamdulillah, I'm doing well. You describe your part. Now it's my turn to describe my part and make you understand
Okay.
all my question part. My question was, does lexicographic preference relation satisfy the weak axiom of real preference? Before start the question answering part, I would like to describe my the two term called lexicographic preference and weak axiom of trivial preference. Lexicographic trivial preference is a hierarchical comparison of quantity of goods. It is a specific kind of preference order in which a consumer ranks all goods based on their priority order. And the weak axiom of trivial preference is a condition in consumer theory which used to test the consistency of observed choice with the idea of rational behavior. So according to my question, there are two hints that we should have to prove this question in two steps. First one is every lexicographic preference relation is rational, and another one is every rational preference relation satisfied with axiom of trivial preference. Uh, so let's consider two lexicographic preference for two consumption set uh, X and Y, where X1, X2 is the bundle of good X. Uh, say for example, X is apple and Y is orange, and X1, X2 is the quantity of apple, and Y1, Y2 is a bundle of quantity of orange. And here, this greater wave equal sign means that weakly preference, and this equation one means that bundle of X weakly preferred than bundle of Y, if and only if the quantity of X is greater than quantity of Y. Or another condition is when quantity of X equal to quantity of Y, or a quantity of X2 greater equal to quantity of Y2. To show that lexicographic preference relation satisfy the rationality, we need to show two things. First one is lexicographic preference is complete, obey the rule of completeness and transitivity. And we will show that the bundle of good X and Y are complete and transitive. Completeness. By definition, this sign is a complete preference relation. When bundle of X1 is not equally, when we say that a bundle of X1 is a bundle of X1 and X2 is complete, we means that bundle of X1 and X2 is weakly preferred than one another. It doesn't mean that it will not be complete if it is equally preferred to each other. So that's why this equally preferred sign is not. And completeness means that Y is weakly preferred than X, or X is weakly preferred than Y. We have to choose one bundle over another bundle. We never choose each bundle simultaneously. Expression 2 describes that bundle Y1, Y2 contains weakly more units of good 1 than bundle X, thus implying that a consumer with a lexicographic preference relation weakly prefers bundle Y1, Y2 to X1, X2. For example, Y1, Y2 weakly preferred than X1, X2. in, sim- in simple, In simply, we can say that lexicographic preference is the order. We order our preference that we prefer apple over orange, or we prefer orange over apple. This is called completeness. And part two, transitivity. Let's take three bundles: x1, x2, y1, y2, z1, z2. Uh, let's say there are three kind of fruits: apple, orange, banana, and this makes three bundles. First bundle is apple, and second bundle is orange, and third Z bundle is banana. And now we show that if we prefer apple over orange, and and if we prefer orange over banana, we actually means that we prefer apple over prefer apple over banana. And this process is called transitivity. So mathematically, we here see that three bundle x1, x2, y1, y2, z1, z2. These all are the quantity of our three groups. In this mathematical expression, we see that bundle x1, x2 is weakly preferred than y1, y2. If and only if x1 greater than y1, x1 equal y1, or x2 greater equal y2. Uh, in this transitivity position, we will show that each of the two bundle will obey the rule of completeness. If each of the two bundle each of the two bundles obey the rule of completeness respectively, we can say that uh, the first bundle x1 will be will complete to the last bundle z2. Then here is the relation of x1, x bundle of x and bundle of y. Then we see the relation of bundle of y and bundle of z. This relation also say that bundle of y is weakly preferred than bundle of z. Uh, and this is the complete relationship. If and only if same condition, y greater than quantity of y greater than quantity of z, quantity of y equal quantity of z, or quantity of y2 greater equal quantity of z2. In these four steps, we will show that each of the two condition, each of the two combination of each of the two condition is they obey the rule of transitivity. And these each of the steps we show the transitivity condition for each of the condition. eh, that is x when x1 greater than x2 and y1 greater than z2, we can say that x1 greater than z2. So this condition obey the rule of transitivity. Respectively, other condition also obey the rule of transitivity. So that's all the part of the lexicographic preference. And then comes the second step. Here we prove that every rational relation satisfies the weak axiom of trivial preference. Before describing, before start step two, is there any question, Ishrat, in first step?
In first step, I have a question. Uh, how do we can construct ABCD?
I already mentioned that we construct ABCD according to the condition. You may see that here uh, here the completeness condition of x1, y1, completeness condition of bundle of x and bundle of y, and bundle of y and bundle of x. This is the condition when y1 greater than x1 and y1 equal y1 equals z1 and y2 equals z2. in that case, bundle of Y is weakly preferred than bundle of Z. So in this 4-point ABCD, we take the combination of two of each of the condition, and we show that they over the rule of transitivity. Let's see. First one, x1 greater than y1 and y1 greater than z1. We can say that x1 quantity of x1 greater than z1. In the second step, when here we write that x1 equal y1 and x2 greater equal y2 and y1 equal z1 and y2 greater equal z2, then we can say that ultimately x1 equals z1. This condition also obey the rule of transitivity. Respectively, in the third case, in number C, when x1 greater than y1 and y1 equals z1 or y2 greater equals z2, we can say that x1 greater than z1. So again, we take another condition and we test the transitivity, and all of this condition holds the transitivity rule. Do you understand, Isha?
Oh, yes, I can understand.
Hello.
You can move to the step 2.
Okay. Let's now prove that every rational preference relation satisfies the weak axiom of reveal preference. As I mentioned earlier, that lexicographic preference is the order of the preference of a consumer. When a consumer reveal their preference in order, if they maintain the order consistently in her every choice, we can say that the consumer over the rule of weak axiom of reveal preference. So here we show these things in mathematical. First, take some budget set B is a subset of universal budget set bold B. Let's assume that x1 and x2, or two goods x1 and x2 is the subset of budget set, and then bundle X is revealed preferred to all other bundles in budget B. For example, X belongs to optimal choice. X belongs to optimal choice set C star. This actually means that from the bundle of B, we choose from the bundle of B, and there are two products, say X and Y. From here, we choose X, and that's make the optimal choice bundle C star. Hence, X1 weakly preferred than Y. To check whether weak axiom of reveal preference is satisfied, suppose that for other budget set B prime means that in first case we choose X from budget set B, and after choosing X from budget set B, the rest of the set we define here the B prime, and B prime also the subset of universal set bold B that also contain bundle X and Y. For example, all XY belongs to B prime. We have that bundle Y is reveal preferred. For example, Y is a subset of optimal choice C star. Now, in our second case, we choose Y over X. This implies that Y weakly preferred than Z for any for any Z belongs to B prime. Since we also had that X weakly preferred than Y, hence by transitivity we can say that X weakly preferred than Y and Y weakly preferred than Z, then X weakly preferred than Z, and X for all Z belongs to B. That means X is the optimal choice. X is a subset of optimal choice C star. Therefore, weak axiom of real preference is satisfied. And that's all my part. Do you have any questions in second step, Isha?
No, you have discussed it very well. I understand most of the part, but I think I will understand more if I read this part again and again, because your question is too critical, but you did very well to make me understand. Thank you, Eva, for your discussion.
Uh, Thank you so much, Ishat, for cooperating with me. Uh, we can end our discussion here. Bye, Ishat.
Okay, obviously. Bye.